friends, myself Professor Khyati Gupta. Here in this video lecture we will see about biotransformation. Biotransformation means the chemical alteration of drug into the body, in which if we administer any parent molecule of drug and chemical alteration of that parent molecule occurs, it is called drug metabolism or biotransformation. For biotransformation or drug metabolism, it is needed to convert the non-polar or lipid soluble compound to lipid insoluble compound, because if we convert this lipid soluble compound to lipid insoluble compound, it will not reabsorb into our renal tubules, because our biological membranes are made up of lipids, and therefore lipid soluble compounds will reabsorb from there and will not excrete. So it is needed to convert lipid soluble compound to lipid insoluble compound, and therefore mostly hydrophilic drugs like streptomycin are little biotransformed and are largely excreted unchanged from the body. And for drug metabolism, many mechanisms are developed because these drugs are toxins if they are not excreted from our body, and these toxins can harm to our body, right? The primary site for drug metabolism is liver, and others are kidney, intestine, lungs, and plasma. This is the classification of drug metabolism reactions that are classified into two types. First is phase 1 reaction and second is phase 2 reaction. Phase 1 reaction or non-synthetic reactions include oxidation, reduction, hydrolysis, cyclization and decyclization, whereas phase 2 reactions include conjugation, acetylation, methylation, ribonucleotide or nucleoside synthesis. Now first is phase 1 reaction, in which first is oxidation. You all know that oxidation reaction involves addition of oxygen or negatively charged radical and removal of hydrogen or positively charged radical. Various oxidation reactions are hydroxylation, oxygenation at carbon, nitrogen and sulfur atom, nitrogen or oxygen dealkylation, oxidative deamination, etc. And the drugs that are metabolized by oxidation reactions are barbiturates, phenothiazines, steroids, imipramine, propranolol, ibuprofen, paracetamol, etc. Right? Second is reduction reaction, which is totally opposite of oxidation reaction, right? In this reaction, we add hydrogen or positively charged radical and will remove oxygen or negatively charged radical. And for this reduction reaction, cytochrome P450 like enzymes are working, right? Now the drugs that containing alcohol, aldehyde or quinone like functional group are mostly reduced, and example of the drugs that are reduced are halothane, warfarin, chloramphenicol, chlorohydrate, etc. Next reaction is hydrolysis reaction, and in hydrolysis reaction a water molecule is cleaved, right? So the drugs that contain ester-like functional group will cleave a water molecule and convert into hydrophilic functional group like acid and alcohol. And for this reaction, the enzyme used is esterase enzyme. Similarly, amides and polypeptides are hydrolyzed by amidases and peptidases enzymes. Next reaction is cyclization reaction. Okay, the name suggests that we cyclize the drug structure. The drug that is activate in open straight chain like structure, right? If we cyclize it, it will be inactivate and will excrete from the body, right? So proguanil is this type of drug. Decyclization, which is opposite of cyclization. This is the opening of ring structure of the cyclic drug molecule, and the example of drug is barbiturate and phenytoin drugs, right? Now phase 2 reactions. So it is a little difference between phase 1 reaction and phase 2 reactions. The drugs which are micromolecules that are metabolized directly through phase 1 reactions, and at the end of phase 1 reaction the drug metabolite is now lipid insoluble, or you can say hydrophilic, and is ready to excrete from the body, right? But some drugs are more lipid soluble and macromolecule drugs. They are passes through phase 1 reactions, but at the end of phase 1 reactions, the metabolite is not ready to excrete because it is still lipid soluble drug, right? So it passes through phase 2 reactions like conjugation, which involve conjugation of drug or its phase 1 metabolite with an endogenous substrate usually derived from carbohydrate or amino acid to form a polar highly ionized organic acid which is easily excreted in urine or bile. So this type of drugs uh, are ready to excrete from the body at the end of phase 2 reaction, which is a complex of endogenous substance and phase 1 metabolite of that drug. Conjugation reactions have high energy requirement and these involve glucuronide conjugation, sulfate conjugation, glycine conjugation and glutathione conjugation. Next is acetylation reaction. The compounds having amino or hydrogen residues are conjugated with the help of acetyl coenzyme A and therefore it is called as acetylation reaction. The drugs that are metabolized by acetylation is sulfonamide, isoniazid, dapsone, hydrolazine, clonazepam, etc. Next reaction is methylation reaction. The amines and phenols can be methylated by methyl transferase enzyme. Methionine and cysteine-like amino acids acting as methyl donors. And the drugs are adrenaline, histamine, nicotinic acid, methyl-dopa, captopril and mercaptopurine, which are metabolized by methylation reaction. Last reaction is ribonucleoside or ribonucleotide synthesis. This pathway is important for the activation of many purine and pyrimidine antimetabolites that are used in cancer chemotherapy. Okay, so this is all about biotransformation phase 1 and phase 2 reactions. Thank you, friends.